Hello, my name is Julie Heath, and this evening I'd like to speak about the learning disability subgroup, Dyscalculia. Dys means difficulty, culia means it's a derivative of the word calculation. So this disability is a learning disability that speaks to the area of math. Let's get into the disability right now by starting with the symptoms. The first symptom is the most important one to consider. Individuals with dyscalculia struggle with quantity. They actually struggle with being able to map numbers with quantities. In a study, and the study included children that some of them were typically learning children. There was a group that were individuals with dyslexia, a group that were individuals with dyslexia and dyscalculia, or at least they were struggling with math, and a group of children that were identified with dyscalculia. In this study, they asked these children to look at the number 2 and the number 9 and determine which one was larger or something. They were having them compare. And in the study, the typically learning children and the individuals with dyslexia that did not struggle with math were easily able to make that comparison, identify the comparison, and decide which one was larger or smaller. While the ones that struggled in math took far longer to determine the value of the numbers and be able to compare them. So this struggle in quantity and being able to visualize quantity and being able to map numbers to amounts is a key factor in this disability. And it's important to understand that, I think, because it just continues to speak to the struggles that a child can have. Another very important struggle to note in a lot of children that struggle in math and have dyscalculia is working memory issues. So you can imagine if you have a child that's struggling with working memory issues and with quantity, putting these two difficulties together helps you understand some of the struggles that I'm going to talk about next. And one more that is very notable, and I've actually noticed this in children, and this makes a lot of sense, is immature counting strategies and being glued to counting by ones. So for example, the child that if he has to determine what 3 plus 2 is, he counts on one hand, I don't know if you can see 1, 2, 3, and then counts on the other hand, 1, 2, and then puts them together, 1, 2, 3, 4, 5. And that plus just counting by ones, the child that's trying to multiply 6 times 7 and counts 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on, all the way up to hopefully determining 6 times 7 if he doesn't lose count. So these are some characteristics that you'll notice. And so then the rest of these just follow. Difficulty understanding place value, number lines, positive and negative values, caring and borrowing, which we now call regrouping or renaming, and then understanding and doing word problems, sequencing, steps in problems, understanding fractions and decimals. I didn't include decimals, but those are very difficult. Making change in money, putting languages to math processes, understanding time, and then organizing problems on a page, being able to line up those numbers and keep everything in order so that maybe doing a long division problem or something like that, the numbers are all sort of all over the place and not in their correct places, and that makes things difficult. And some of these attributes, you can see the overlap between the learning disability dyscalculia. I'm sorry, I'm going to pronounce it 2 different ways because experts in the field pronounce it 2 different ways. I'm trying to be consistent. So please bear with me, but the individuals with dyscalculia, that's how I'm trying to pronounce it, that some of the attributes that they struggle with are the same struggles that individuals with other LDs struggle with. So you can often see those similarities. For example, individuals with dysgraphia, they're going to struggle lining up numbers as well. Many of these children are going to struggle with working memory. So those are the difficulties. So how can we help these students that we have? Well, I love the fix, and I found this on the site that we did our first module in, IRIS, and I have that cited later in this PowerPoint presentation. But I am a dyslexia specialist, and I studied Orton Gillingham for reading instruction, and so it does my heart good to have found out that the fix, or the intervention for these children that struggle in math, is explicit systematic instruction. That makes so much sense to me. I think that's often just the fix for children with learning disabilities. And so here are some attributes in the field of math. The teacher is going to have to identify the skill to be learned for the student, is going to have to connect that learning with previous learning. That's so important. That's that systematic part. They can't make those connections. Those connections need to be explicitly taught to them. The teacher will give precise instruction, and then will provide scaffolded, guided, and independent practice, and lots of it. And that's difficult for me, because I understand that these children probably have, or could have, fine motor difficulties, slow processing, and it's very difficult to know that they're going to need this extra practice, but it is a component that will help them. The teacher is going to encourage them to verbalize the strategies that they're using, provide corrective feedback all the time, and maintain learning, meaning that cumulative review. And when I picture providing corrective feedback, I picture that teacher in that UDL classroom, all of just walking around, helping this group, helping that student, double checking, not letting anyone fail too far before being able to catch them and help them and bring them back to the understanding what they need to be doing in the lesson. So the components of the UDL lesson in the classroom, the first part I wanted to address was the representation, and I actually have a lot for this part. I think teachers have to be really designing their lesson to help the students to get started. So that first part of the lesson, that representation. First of all, children who struggle in math, again, they're struggling with the idea of quantity, and they're struggling visualizing the ideas of quantity. This can be seen if you look at struggling children's Iowa test. A lot of our private Christian schools have Iowa testing. If you look at the cognitive part, the second part of that test, and look at the nonverbal section, a lot of time the same children who are struggling in math have very low nonverbal scores. And I really think that there's a connection there. And so very often these children, they can't visualize these math concepts and all of these number concepts and the way numbers work in place value and on the number line in their heads. And so they need manipulatives like cubes, blocks, fraction circles, Cuisenaire rods, sometimes those are called, or additionally 10 blocks are another manipulative. And then three-dimensional shapes to find things like area. I have an example of that. I know of a student in 6th grade, 7th grade math that was struggling and just couldn't look at the pyramid drawn on his test or his worksheet and be able to determine the area because he couldn't picture the sides that you just kind of obviously assume, or I as a helper just think, well, of course it's a pyramid, so you have to kind of pull that off the paper and kind of visualize the other sides. That child needed an actual pyramid to hold in his hand, a little wooden pyramid, so that he could count the sides and find the area for all of that, and then look at the bottom and see what it looked like. So that's just an example for that. Coins, clocks, all of these manipulatives. And the thing I want to point out here that I am assuming and want to learn about is the fact that in the kindergarten, first, second, and maybe even third grade classroom, we have the manipulatives going. But I think what might need to be understood by me as a resource room teacher coming up is that those manipulatives need to continue into the 5th grade classroom all the way up to like the 7th grade classroom, the 8th and 9th, the geometry classroom, and 10th grade, and so on. And so that, yes, most of them have completely unglued or disconnected from the need for manipulatives, but this group of students that we're discussing, they still need those hands-on. They need to be able to see, touch, feel the manipulatives to make connections in math. And so I think that sometimes maybe a 7th grade teacher is going to have to, go downstairs to the 1st grade room and borrow some manipulatives for a couple of her students or his students. And I just wonder about if that would be helpful. And I think it would be. Another part of visual representation to help these children that do not visualize very well would be, it's called visual representation or schematic representation. And so instead of actually these manipulatives that they can feel and touch, we're talking about things like drawings and strip diagrams. And I love this one, this decimal grid, because again, back to their sort of immature way of looking at numbers. A lot of times when these types of students see a number, say it's as this example, say it's 0.05, if they see a 5, it's a 5. That's all that they can think of. It's a 5. We learned this in kindergarten, this is a 5. And they cannot picture what that 5 means because of its place and because of an illustration like this could help them to be able to understand that we're talking about 5/100ths. 0.05 means 5/100ths. And I think this maybe would speak to some of them, being able to see it like this in a visual representation. Of course, not all of our math students who are struggling are visual learners. And so while they do seem to really all have that difficulty with visualization, they might not be visual learners, and so it might be that a presentation using their auditory strengths and their language strengths might help them. And so making math memorable by using mnemonics could help them. Here's a little mnemonic about c times pi times diameter and so forth. And then also having them, some of these students, giving them the opportunity while they're learning to verbalize what they're learning about or write about what they're learning about might help them. Some of them will have no language deficit at all, and they will be very good writers or very good speakers and receive things well auditorily. And so some of these ways can help them as you present your lesson. And then I was watching the video, the FAT City video, F-A-T City video that we were to watch, and the instructor was speaking about how people are only able to engage in one cognitive task at a time. And so when you think about the struggle that these students would be having with quantities and visualizing numbers and place value and all of this, that's where all of their cognitive load is going as a teacher is making her presentation or his presentation. And so they are not also going to be able to necessarily take notes on it at the same time, especially if they have fine motor struggles as well. If they're struggling with, maybe it's an individual with dysgraphia as well, because sometimes they co-occur. And so teachers need to provide filled-in notes for these students, and provide maybe filled-in graphic organizers so that when they get home, they have something to review, because they might have been putting all of their attention into engaging in the lesson in class and not being able to write any of it down. The presentation continues in the fact that according to Iris Peabody, this Iris module that I viewed today, it is very helpful, especially for older students, to have all 3 types of presentation at the same time. Now, developmentally, sometimes the little guys, they need just the concrete for several days. Then we're going to move them into the visual representation and then the abstract all by itself. But as they get older, apparently it's very helpful for them to have all of this simultaneously and lots of verbalizing about it. So they actually have